Hello tech community, welcome to P-TekLearn. In this series of 108 practice questions, I will walk you through 108 of the most commonly asked questions that can help you pass the AWS Certified Solutions Architect Associate exam. For each question, I will explain the correct answer in detail on each slide. If you have any questions or need further clarification, feel free to ask in the comments section. Before we begin, I request you to subscribe to our channel and enable notifications so you will be alerted whenever a new video in the series is released. Let's see the question number 1. As a solution architect, how could you ensure that the new objects being uploaded to an S3 bucket in one region should be available in another region as well? Okay, I think you understand the question. So whenever user uploads an object into an S3 bucket which is created in one region, should be available in an S3 bucket that is created in another region as well. So this is basically replicating the objects that are being uploaded to an S3 bucket. Okay, so let's go through the options. Create an S3 snapshot in the destination region. Snapshots are basically used to take the backup of an existing S3 buckets. It's not to replicate each object while upload is in progress. So option A is not the correct answer here. Option B. Use a Lambda function to copy the objects to bucket in the destination region. Okay, using a Lambda function that can be done, but it's a overhead. The object needs to be automatically copied to another bucket in a different region. So this option is not viable. Option C. Enable cross-region replication on the bucket. This is the right answer. So we are looking for replicating the objects that are being uploaded to an S3 bucket. So this is an option, that is a configuration which can be done at a bucket level in S3. So that enables automatic asynchronous copying of objects across buckets in different AWS regions. So option C is the right answer. So what is the option D here? So create S3 lifecycle methods. No, that's not the right answer. Question number 2. A media company is planning to store their video files in AWS for a period of 15 days with a frequent access option. Okay, so what could be the cost-effective solution for them? So this company wants to store all those video files that they create for their business and store them for a period of 15 days. And they will access these files frequently. And after 15 days, they want to delete them, right? So what is the cost-effective solution? Option A. Store the video files in S3 Glacier and use lifecycle policies to delete them. No. The purpose of S3 Glacier is for the long-term storage. So this is not the right option for this use case. Option B. Use Amazon RDS to store video files and run a batch job to delete them. This is obviously very expensive solution. Storing the video files in databases is really expensive. So this is not the right one. Option C. Use NFS file system to store video files and then delete manually after 15 days. No. So deleting the files manually is an expensive task. It's an overhead. So the final option D is the correct answer here. Store the video files in S3 bucket and use object expiration policy to delete them after 15 days. Perfect. So this is how we can delete the objects after using for 15 days automatically by setting object expiration policy. So D is the right answer. Question number 3. An application is running in US East 1, requires 6 EC2 instances running all the times. Okay. So what could be the best deployment solution to achieve fault tolerance if one of the ASIS availability zones in US East 1 is down? Select 2 options. Okay. To understand the question properly, this application requires 6 EC2 instances running at any given point of time. And these instances are deployed in US East 1 region. And US 1 East region, they have some availability zones, right? Let's take 3 availability zones from East 1 region. And here the requirement is we need to achieve fault tolerance if one of the availability zones in this region is down. So if out of 3 availability zones, if one is down, still the application needs to be up and running with 6 EC2 instances. So that is our requirement here. Let's see. Option A, 6 instances in US East 1A, 6 instances in US East 1B, and no instances in US East 1C. So here, if you look at this option, if any of these 3 availability zones is down, say for example, US East 1A is down, we still have 6 instances running in US East 1B. So that meets our requirement. Okay, let's look at the next option, B. 3 instances in US East 1A, 3 instances in US East 1B, and 3 instances in US East 1C. So here they want to deploy 3 instances on each of these availability zones. So if one of these 3 availability zones is down, still we will have 2 availability zones with 3 plus 3, 6 EC2 instances up and running. So this is also another option we can go with. So we do not need to look at the other 2 options, but just look at them. 3 instances in US East 1A, 3 instances in US East 1B, and no instances in US East 1C. Okay, so as per this option C, if East 1A instance is down, then we will have only 3 instances running in US East 1B, right? Since there are no instances running in US East 1C, we will not achieve the fault tolerance, which is our requirement here. So C is not the right answer. D, option D. 2 instances in US East 1A, 2 instances in US East 1B, and 2 instances in US East 1C. If one of these 3 availability zones is down, then we will left with 4 instances running on 2 other availability zones. So option D is not correct. Question number 4. A few microservices are deployed in VPC 1 and VPC 2, which are able to communicate with each other. So there are 2 VPCs. Okay, there is a new requirement to allow couple of microservices running in private subnets of both VPC 1 and VPC 2 to connect to the internet. But no one from outside of these 2 VPCs should be able to reach the microservices. As a solution architect, what's your solution for this use case? Okay, so to understand this question, there are 2 VPCs running with some microservices deployed. And these microservices are able to communicate with each other. But the new requirement is they should be able to connect to the internet to perform some operations. But no one should be able to connect to these microservices from out of these VPCs. So that should be secured. Okay, so let's go through the options one by one. Option A, create an internet gateway to VPC1 and route VPC2 traffic to VPC1. No, that's not at all correct. Why do we need to route the traffic from one VPC to another VPC? So this is not the right answer. Option B, create a NAT gateway in VPC2 and route VPC1 traffic to VPC2. Again, same thing. Whether it's an internet gateway or NAT gateway, we do not need to route traffics from one VPC to the other one. So B is also not correct. Option C, make the subnets in public. Come on. So if you make both subnets are public, then there is no security, right? So anyone from outside of these VPCs can connect to these microservices. So which is not our requirement here. Option D, create a NAT gateway in both VPCs and configure routes for each VPC to use its own NAT gateway. So this is the correct option. This is the right solution for this use case because each VPC will have its own NAT gateway and do not need to route the traffic from one VPC to another VPC, and also the external users or sources could not connect to the microservices. So the option is D here. Question number 5. Your team needs to install a 200 GB volume on an EC2 instance for their API. The data usage is very less frequent with small peaks in the daytime. As a solution architect, what's your cost-effective solution for their requirement? Okay. So option A, Amazon EBS Cold HDD. So this is the right answer. We do not need to look at the other options. But so let's try to understand why this EBS Cold HDD would be the right solution for this requirement. The volume data is used infrequently and not throughout the day, right? So only at peaks at the daytime. And the question requires the most cost-effective solution. So the cost-effective storage type. So the preferred choice would be Amazon Cold HDD. Cold HDD is suitable for the following scenarios: throughput-oriented storage for data that is infrequently accessed, scenarios where the lowest storage cost is important. So the correct answer is A, Amazon EBS Cold HDD. Option B, Amazon S3 Glacier is for the permanent storage and long-term storage. Amazon EBS General Purpose SSD. So totally this is for large volumes of data and for the permanent storages. Option D, Amazon EFS, same thing. So we can store the data in EFS for long-term storage purposes, and it is not cost-effective. It's very expensive. So that's it for this session, guys. In the next session, let's go with another 5 most frequently asked questions. Thank you for watching our video. If you like this video, please like it and then subscribe to our channel. See you in the next video. Bye now.